So let X be the speed of a car in the school compound or whatnot. Just define the unbiased estimate. Just imagine, right? This security card, right? It just feels that the car in front of the school, like just travels faster out of the speed limit, which I think oftentimes it is. So to investigate the security guards claim the traffic police randomly selected 50 cars, and the speed was recorded. So the total speed and the standard deviation of the 50 cars are found to be 1325. So this one here is your summation of X, the total speed. Whereas this one here is what? Can someone tell me what is this? This one, yeah, 7.75 km per hour. Very good. Sample standard deviation. Okay, that's sample standard deviation. Very good. So this is it. So know how to extract. So remember, this 7.75 is all your secondary school. When they ask you to find standard deviation, right? The standard deviation that you get out of your secondary school, those are all sample standard deviation. Okay. So that's one. So find the unbiased estimate of population mean and variance. So unbiased population mean would be 1325 over how many cars are there? There are 50 cars. Very good. Then, oh my goodness, sigma x is what is sigma x? 7.75. 7.75. Okay. So this is it. For x bar sample mean is quite straightforward. What you get is 26.5. Then s square would just be, you need to use the formula n minus 1 sigma x squared. This is where you need to use this formula. This formula, please memorize. Please memorize it. Please memorize it. Okay. So I'm just gonna copy from what I wrote on in the Wednesday class. Okay, great. Then after that, you are testing. You're carrying out the test for the security guard. Part 2. So I think this is okay. So what we need to do is part 2. Part 2 will be let X be the speed of the car. School compound. You can just define a mu. If your school wants you to define, just follow it. Yeah, H now is mu 25 km per hour. Mu 25 km per hour. Whether you're speeding or not, more than. Under H now, test statistic. You need to use CLT because the population is not normally distributed. Approximately by central limit theorem since n is large. How many cars are there? 50. Okay, so n equals to 50, x bar 26.5, s squared equals to 61.288, alpha percentage equals to 5%. Okay. Now, whether you reject or not. Now, because I know part 3 need to use p-value, so I'm just going to use p-value because part 3 is using 20% level significance, right? So without any further test, this is the one which I need to go through with you. But we just use p-value to reject or not. Okay. So I said p-value is very easy. P-value basically just means if p-value is bigger than alpha, you don't reject H now. If p-value is less than alpha, you reject H now. Okay. So this test here, what we're going to do is just bring out a GC, calculate the p-value. Okay, so I'm just going to calculate the p-value up. This is it. Bring our GC up, and I usually like to draw the normal curve lah, because it's easier to visualize. So stats test statistic mu naught is 25. That is what the Jaga at the school claims it to be. And then sigma would be root of S. This is S, unbiased estimate. You don't have the gold standard of sigma, you just use unbiased estimate. Estimate it lah. All right. So this is 61.288. Okay. Root of it. Oh my goodness. Hang I check. So 61.288. Okay. This one, root, make sure you square root it. Please, let's just do this together. So X bar is 26.6. If you have a GC, just key in, find your P values. Then N is 50. 50, right? 50 cars. And then you want it to be more than, and I'll prefer you to draw. Pick your color. Let's see what color I like. I like blue. Of course I like blue. Not like, okay, so this blue is very nice actually. I like this blue. It's very close to my brand color. So yeah, that's why I like this blue. How? So this is your p-value, z-test. Take it down. You can use another sigma value if you want to. Just key in. Put it in here. P-value, yeah, that's it. I'll come and help you. Come. So yeah, in exam you just write from GC, p-value is what? Yeah, that's it. Coming to you. Okay. So from GC, the p-value will just be 0.0877. So this is actually more than alpha percent. What's the alpha percentage? You're testing 5%, right? This is more than 5%, which is this is 8.77%. So if this is 8.77%, so do not reject H naught at 5% level of significance. My goodness. Well, we conclude that we don't have sufficient evidence to state that the mean speed of cars has increased. Okay, in context of the question. So you just straight away just like, hey, security guard, don't anyhow say. Hey, you don't have enough evidence to say that people speed in front of the school. So for part 3, without any further tests, the easiest way is this, use the p-value method, because now if the police want to see that the average speed of car is not 25 km/h, so your H now mu is 25, the alternative will be mu not equals to 25. Means you can either hogging the road or you can speed. Means you can be slower than like you drive a car at 5 km/h, or you're like driving like 100 km/h, right? So the thing is not, so it's two-tailed. Without any further test, take the conclusion. If instead we test at alpha percentage, 20%. Okay. Now everything remains the same. So when you're doing okay, method 1, the easier one will be the p-value method. Okay, this one just take note. So when you're using the same curve here, okay, this is your z-stats, right? This is your p-value, right? For one tail, right? This is your p-value. This is your p-value. So
for everything stays the same, right? So, but when you change it to two-tail, right, your p-value will replicate on the other side. It will be replicated. So the new p-value, it will be replicated. The new p-value is actually 2 times the old p-value because it replicated. That's all. So it just 0.0877. So if you want to use the p-value method, just remember the p-value method, the p-value for one tail and p-value for two tail. If everything stays the same, means the sample size is the same, everything the same, right? One, you multiply by 2, you get the two-tail p-value. You divide by 2, you get the half a tail, because basically that's how we compare. We just take the one tail p-value, we just replicate over to the other side. Okay, that's one way. Method one is just take the new p-value will be 2 times the one tail p-value. Okay, either you understand it from this perspective or just memorize because usually this question won't carry over marks, so it's like 1 mark. So if you feel that you don't want to cram too much things in your head in terms of understanding it, then you just memorize. Okay, that's one way. It's method one, p-value. So this one ultimately will get you 70%, which is actually less than 20%. So hence, reject H naught and conclude. This is method one. So this is actually 1. Can you just put this as 1 tail p-value? It's easier. 1 tail p-value is here. So when you change to 2 tail, you just multiply with 2, replicate over. Okay? There's another method which some of you are already thinking, which is to just compare with the Z method, because now you're using 2 tail. It means you use a boundary, you compare. There's not much test left, so you're using 2 tails, so this is 10%, this is 10%, right? Then you actually find what is this boundary here, the Z critical. Then because you already have the OZ stat, the OZ stat is this is without any further tests. The OZ stat is this one here. We already found 1.354, which is also given in 1.3548. Then you just use GC to find this boundary, inverse norm, right? Okay. Distribution inverse norm. 1.281. Then you just reject. Okay. Actually, also can. This is no further test. So this is the OZ stat. Then you just compare. This method 2 then seems more than 1.281. Check. Classical. So method 2 is classical method. What's method 3? It's the same thing. Method 3 is nothing interesting. It's the same. Actually, it's the same as method 1. So I'm not going to go through that. So there are 2 methods. One using classical, one using p-value. So p-value, you just take the 1 scale, multiply by 2, then you just compare. The classical one is quite straightforward. You just 10%, then you find the critical version, then you just compare. Okay. Any question, please ask. If not, you can try the subsequent question.